So continuing with our fun with fractions, moving on to part 3, nested fractions. Still looking at the same learning goals as the two parts before, adding, subtracting, multiplying, dividing fractions. But this time, we're going to look at it in a different way. We're going to look at probably something that you haven't seen before. Occasionally in Algebra 2, there's time to focus on these types of questions, but they don't tend to be a major focus in Algebra 2. In Pre-Calc and beyond, these types of questions come up enough that I want to make sure that we spend some time at the beginning because it's going to come up over and over and over again throughout this year. A nested fraction. Now, I use the word nested. Some other teachers or textbooks or websites that you research this topic on may refer to this as a complex fraction. I tend to avoid that particular terminology because the word complex means something different in different contexts. So I like to refer to these as nested fractions, which is another common way to refer to these as. And the word nested is in the same sense as, say, a Russian nesting doll, if you've ever seen one of those. Those are the little toy wooden dolls that you have a doll inside of a doll, inside of a doll, inside of a doll. Those are called Russian nesting dolls. So to nest something is to put something inside of something else. So if I look at these two fractions, I have a over b and c over d. If I were to get rid of the a and place the c over d where the a used to be, what I now have is a nested fraction. I have a fraction inside of a fraction. So the c over d is inside the fraction a over b, where a was replaced with c over d. Just as easily, I could nest the fraction into the denominator of the original fraction, or I could nest two separate fractions inside of a single fraction. So I have a over b nested in the numerator, I have c over d nested in the denominator. Regardless of where I put the interior fraction, I have a nested fraction, a fraction within a fraction. So nested fractions are essentially fractions within fractions. And if you want to get really crazy, we could nest fractions within fractions within fractions within fractions, but that would just be for fun. I'm not actually going to throw anything like that at you this year. But the reason I'm focusing on this particular topic right now is because, again, as I said before, nested fractions show up all the time in pre-calculus and beyond, and you need to be able to work with them quickly and efficiently. So let's start with an example. Here's a nested fraction, 3/2 divided by 5. Now we're going to look at this example three different ways. We're going to look at it the most straightforward way, then I'm going to look at a shortcut, and then I'm going to look at a shortcut to the shortcut. And that third way we do it is going to be the way I'm going to do it in pretty much all situations. But as you get to learn my teaching style over the next year, you're going to learn that I don't like just showing you the shortcut. I want to show you where the shortcut comes from so that you have a true understanding of why that shortcut works in this situation, but it does not work in a different situation. Because the thing with shortcuts, if they worked in all situations, then we wouldn't call it the shortcut, we would just call it the way to do it. So let's start with the way we do it, and then see if we can simplify that process and then simplify it a little bit more. Let's start with realizing what this fraction actually says. 3/2 divided by 5. Okay, take the number 3/2 and divide it by 5. So option 1 is to rewrite 3/2 divided by 5 as 3/2 divided by 5, literally using a division symbol instead of a fraction bar, and then follow the keep it, change it, flip it technique. Anytime I have a nested fraction, feel free to expand it out into what I would call the elementary school notation, and then just follow the elementary school technique. That's the official way to do this problem. So 3/2 divided by 5 is 3/2 division symbol 5, keep it, change it, flip it, multiply straight across, we get 3/10. The correct answer to this question is 3/10. Now, as easy as that is, which again, I don't mind if you use this technique, that's perfectly fine. But as the problems get more complicated, it's nice to have a simpler technique in your back pocket. And we always practice those simple techniques on the easy problems first before we apply them to the hard problems. The slightly simpler technique is called clearing the fractions. Now, this particular technique is going to come up a lot throughout the year, although on this problem, I'm going to show you another option that will allow you to simplify this problem a little bit quicker than the clearing the fractions option. That idea of clearing the fractions is going to pop up from time to time throughout the course, so it's helpful to talk about it right now, even though it's actually not the technique that I prefer to use on this particular example. The idea is I don't like working with fractions. Okay, so let's get rid of the fractions by clearing the fractions. The way you can get rid of a fraction is simply multiply that fraction by its own denominator. If I take a fraction, 2 over 7, and I multiply it by 7, the 7's cancel out, I'm left with 2. If I want to get rid of a fraction, multiply it by its own denominator, and poof, no more fraction. Now, of course, when I'm actually simplifying something, I can't just arbitrarily multiply unless I make some equally compensating move somewhere else. If I'm solving an equation, the rule is whatever I do to one side of an equation, I have to do to the other side of an equation. So, for instance, if I had 2 over 7 times x equals 4, well, sure, I could multiply the left by 7, multiply the right by 7. That clears the fraction on the left and leaves me with some new number on the right, and I can proceed forward with that particular problem. But we're not solving equations here, we're simplifying fractions. And the rule with fractions is whatever I do to the top, I must also do to the bottom. So that's what we're going to do here. In order to simplify a nested fraction using the clearing the fractions technique, multiply the top and bottom by the denominator of the interior fraction. In this case, the interior fraction is 3/2. So the denominator of the interior fraction is 2. I want to clear that denominator out. In order to do that, I'm going to multiply top and bottom of the overall fraction by 2. So when I multiply the top by 2, 2 times 3/2, the 2 cancels out. We're left with 3 on the top, and then 2 times 5 on the bottom is 10. And hey, look at that. We got the exact same answer that we did before in option 1 using what I like to call the elementary school process. I still got 3 over 10, but notice there's a lot less work to show when I'm using this technique called clearing the fractions. Just multiply top and bottom by the extra denominator that you have. That clears out the fraction, and you're left with your answer. I like that technique. That technique's going to come up a lot this year. Now, before we move on to option 3, I just want to take a moment to give you 3 more examples for you to try. I want you to evaluate each of these expressions using the clearing the fraction technique. Pause here, hit play when you're ready. All right, we have 4/5 divided by 3. So the interior denominator is going to be 5. So if I multiply top and bottom by 5, that's going to cancel out the 5's. And it's going to leave me with a 4 on top and a 15 on the bottom. Second one, notice the nested fraction is actually in the denominator. So I'm going to take the denominator of the denominator, 7, multiply top and bottom by that 7. So multiplying through on the bottom, the 7's would cancel out, clearing the fractions. I'm going to be left with 2 on the bottom and 49 on the top, 49 over 2. Now looking at this third one, notice we have nested fractions in both the numerator and the denominator. Okay, we're going to follow the same process, clear the fraction by multiplying by the interior denominator. But in this case, we have 2 separate denominators that need to be cleared out, the 3 and the 2. Well, again, keep in mind this is multiplication. It doesn't matter what order you multiply in. You can multiply top and bottom by 3 and then multiply top and bottom by 2. That's perfectly fine if you want to do this in 2 steps. Or wouldn't it be easier just to multiply by 6? If you have to get rid of both the 3 and the 2 by multiplying, then what you're really multiplying is 6. So when I have multiple fractions that need to be cleared, I can either do it one fraction at a time, or I can just multiply by the common multiple. In this case, multiply top and bottom by 6. So on the top, I'm going to have 6 times 1/3, which keep in mind is really 6 divided by 3. So 3 cancels with the 6. I'm left with 2 times 1, which is 2. And on the bottom, I have 6 times 5/2. Keep in mind, I'm going to do 6 divided by 2 first, which leaves me with 3. 3 times 5, 15. So 2 over 15. Now, as is the case with a lot of different mathematical techniques, notice I'm showing a lot of steps here. I'm showing my work a lot because, of course, I'm instructing here, so I'm always going to show my work when I'm instructing. But when I'm doing this on my own, I don't always show all of these steps. A lot of these steps I do in my head because there's not a lot to keep track of. Using the option 1 technique, the elementary school technique, there's a lot of steps to keep track of, so you really need to write it all out. But the beauty of clearing the fractions is that you could, since there's not really a lot of steps to keep track of, it's easier to keep track of in your head. And because you're doing a lot of these steps in your head, after you do this enough times, you start to realize, wait a second, there's a quicker way here. And that's what option 3 is going to be. Option 3 is simply move the denominator. The denominator that you're trying to clear out, in this case the 2 was the one that we were trying to clear out. What I did in option 2 was I multiplied top and bottom by 2, which allowed me to clear out the denominator here, and it left a new product on the bottom, 2 times 5. Well, if that's the case, just move the 2 downstairs in one step. The quickest way to simplify a fraction within a fraction is just take the denominator and move it either up or down, depending on where the interior fraction happened to begin. In this case, the 3/2 is in the numerator, so let's move the denominator 2 down to hang out with the 5. And when I do that, the division problem becomes a multiplication problem, because of course we're still technically doing keep it, change it, flip it. Division becomes multiplication, which of course simplifies to 3/10. Now again, in my head, I'm probably not going to write this step out. I'm only writing it out because I want to show you what I'm doing. But in my head, I would just see 3/2 divided by 5. I would look at this and say, okay, if I move the 2 downstairs, that's a 10. Final answer, 3/10. No work to show, just do it in your head by moving the denominator down. Works the same way as if the fraction is in the denominator of the overall fraction. Now, the common mistake here is to misinterpret the rule. The rule says to move the denominator up or down. So we move the 2 down to the 5, and we misinterpret that as being, okay, the 2 was closer to the overall fraction bar, so that's why I moved the 2. So in this case, often what people do is move the 3 up and say 15/2, final answer. But 15/2 is not the correct answer. What I'm supposed to do is move the 2 up, move the denominator upstairs to hang out with the 5, multiply through, and I get 10/3. Because notice, all I did is I took 3/2/5 and flipped it upside down, so it would make sense that the answer itself should be the reciprocal of 3/10, which is 10/3. The key is move the denominator. Just move the extra denominator either up or down as appropriate. Just like we did before, here are 3 examples. I want you to evaluate using the move the denominator technique. I don't want you to clear the fraction. I don't want you to keep it, change it, flip it. I want you to specifically practice move the denominator. Let's see what the answers are. Pause here, play when you're ready. All right, so moving the denominator, just move the 5 down to multiply by the 3. You're going to get 4/15. Here we're going to take the 7, move it upstairs. 7 times 7 is 49, so I'm going to have 49/2. And here I have 2 separate denominators, so let's move them both. The 3 is going to come downstairs, the 2 is going to go upstairs. When I move the 3 downstairs, it's going to be multiplied by the 5. When I move the 2 upstairs, it's going to be multiplied by the 1. So 1 times 2, 5 times 3, that's going to be 2/15. Now, of course, I hope you recognize these as the exact same questions we went through in option 2. We just used a slightly different technique. And I hope you agree with me that the quickest option here is option 3. Just move the denominator. Do the mental math in your head and get the right answer 100% of the time. Now again, this technique is not going to always work. We'll talk in the next part, in part 4, about situations where we have nested fractions and this move the denominator technique doesn't work, in which case we'll fall back to option 2, which was the clear the fractions technique. But when you simply have a fraction over a fraction, or a number over a fraction, or a fraction over a number, this is the quickest way. Just look at it, move the denominator, you're done. So to summarize, given a fraction of the form a/b over c, we're just going to move the b downstairs. So the b was here, it moves downstairs, and it's now a multiplication problem. Again, that's because this is based on the overall official technique of evaluating this, which was keep it, change it, flip it. If I were to do this the long way, a/b divided by c can be rewritten as a/b divided by c. Keep the a/b the same, division becomes multiplication, c becomes 1/c, because it's the reciprocal of c/1 is 1/c, and when I multiply through, I get a/bc. The idea here is if I have something like this, instead of wasting my time using the elementary school technique, I can just go straight to this. Likewise, if the b is downstairs, we can simply move it up, because of course if I have c divided by a/b, that becomes c times b/a, which of course is just bc/a. And finally, if I have a/b over c/d, a fraction over a fraction, b goes downstairs, d goes upstairs, the a and the c don't move at all. It's just the interior denominator that moves, the b and the d. All right, just for more practice, here are 6 more examples for you to try. You are welcome to use either clearing the fractions or the moving the denominator technique on these. Again, we are focusing on learning new material, so I really recommend not practicing the option 1 technique. You spent all of elementary school and middle school practicing that. Let's practice some new stuff to kind of move things along a little bit faster as the topics get more complex. So either the clearing the fractions or the move the denominator, although I recommend using move the denominator on all of these examples. Pause here, play when you're ready. All right, so running through all 6 of these real quick, I am exclusively using move the denominator on all of these. If you use the clearing the fractions technique, that's fine. You'll get the same answers I get. So if you don't get the answer I get, hey, maybe look at your work and see if you can find your mistake. So 7 over 2/3, just move the 3 upstairs. 7 times 3 is 21, so you get 21 over 2. Again, I'm writing this step just to illustrate how I got from here to here. Typically, I wouldn't bother writing that step. Question B, 1/9 divided by 2, move the 9 downstairs. That's going to be 18. So final answer, 1 over 18. Also keep in mind as we're going through, again, I'm using the move the fraction down. Move the denominator down. But you can treat that the same thing as clearing the fractions. If I multiply everything through, then that would be the work for clearing the fractions. Moving on. This time we're going to bring the 9 down. 3 and 9 is 27, so 4 over 27. 6 over 4/3, bring the 3 upstairs. 6 times 3 is 18 over 4, but we're not done until we're done. Remember the directions say simplify. 18 over 4 is, of course, 9 over 2. So next we have 1/5 divided by 3/2. We're going to bring the 5 downstairs, the 2 upstairs, leaving 1 times 2 on the top, 3 times 5 on the bottom, or 2 over 15. And finally, 3/2 divided by 5/4. 2 moves down, 4 moves up, so 3 times 4 is 12, 5 times 2 is 10, which reduces to 6 over 5. Now before we wrap this up, I want to look at these 2 examples a little bit closer, just to point out, again, we had a situation where we had to simplify at the end. Feel free to do it that way. If you like simplifying at the end, go right ahead and simplify at the end, but as I discussed in part 1, sometimes it's easier to simplify from the beginning. Remember that a over b divided by c over d is equivalent to the statement a over c times d over b, which means a over c can be reduced just like d and b can be reduced. Those are vertical fractions and you can reduce vertically. So when I see fractions within fractions, before I move the b down and the d up, I could start by simplifying a and c. I could simplify b and d, and keep in mind I could also still simplify a and b. I could simplify c and d, but what I cannot do is simplify the b and the c. Remember that the b and the c, when we do the keep it, change it, flip it, are actually horizontal. You can't simplify horizontally. You can simplify vertically. You can simplify diagonally. A and b can be simplified. A and c can be simplified, but a and d cannot be simplified. So when I look at fractions like these, sure, I could just move the denominators and simplify at the end, or I could recognize, hey, I see 5 and 5, that is a vertical opportunity, so I can actually just cancel out the 5s and be left with 3/4. I don't have to move anything because the 5s cancel out completely. Similarly here, 3/2 over 3/5. The 3 and the 3, they're both in the same position, numerator over numerator, just like I had denominator over denominator. They're the same position, so they can be simplified. 3 over 3 would cancel out, but be careful. In this case, the answer is not 2/5. Don't make the mistake of thinking that this one is going to work out the same way the previous one worked out. In the first example, the 5s were denominators. When I cancel the denominator, it leaves behind a 1. 3 over 1 is just 3. In this case, the 3s were numerators. Cancel out the 3s, leaves behind a 1. 1 over 2 is not 2. It's 1 over 2. So in this case, the numerators cancel out, sure, but it leaves 1 over 2 over 1 over 5, and then move the 5 up, move the 2 down, we get 5 over 2, not 2 over 5. And the last one, don't make the mistake of canceling out the 5s. This 5 is a denominator, this 5 is a numerator. They're not the same thing, they cannot be canceled. What I can cancel, though, is the 5 and the 10. 5 over 10 reduces to 1 over 2. I'm not going to bother writing the 1 because the 1 is a denominator, and that would just overall become 3. So what I have is 3 over 5 halves, move the 2 upstairs, I get 6 over 5. But another option on that one, instead of simplifying this 5 over 10, I could simplify this 5 over 10, because simplifying individual fractions is still an option for me. In this case, it simplifies the same way the previous 5 over 10 simplifies. The difference is, after simplifying, instead of having 3 over 5 halves, I now have 3/5 over 1 half, which then move the 2 up, move the 5 down, we end up with the same answer. It doesn't matter which way you simplify. What does matter, though, is if you try to simplify this way and you're left with 3 over 1 and 1 over 10, and then move the 10 up and I don't care about the 1, and you get 30, well, that doesn't make any sense, because the two previous ways I did this problem, I get 6 over 5. 30 is not the correct answer. If you try to simplify using incorrect rules, you're going to get incorrect answers. Now, taking everything we know and applying something unique that we're not going to see a lot of in the next few weeks, but you're going to see a ton of when we get to the trig chapters in the middle of this course, I decided to go ahead and throw these at you just for fun. Why don't we just go for it? So look at these examples using the rules and techniques that we've gone over in this lesson. Pause here, hit play when you're ready. If you're absolutely stuck, feel free to just watch me do the first one and then pause at that point. So looking at the first one, we have 2 pi over 1/2. Keep in mind, 2 pi literally means 2 times pi. It's just a multiplication problem. We're following the same rules and order of operations as always. I see a fraction within a fraction, so I'm going to move the 2 upstairs. That gives me 2 pi times 2 over 1. The 1 no longer matters. It's just 2 pi times 2. The answer is 4 pi. The pi is nothing special. It's just there. For now, it's just there to be there. But later on this year, you'll see why it's going to show up a lot. Moving on to h, 2 pi over 3 over 2. I've got a couple of options on how I want to proceed here. One option is just to move the 3 downstairs and then proceed like normal. That would be 2 pi over 6, but of course here the 2's cancel out. So why bother writing 2 pi over 6 when I could just as easily write pi over 3? Keep in mind I could have canceled the 2's from the get-go, because of course this 2, you can think of it as 2 over 1. Numerator over numerator, 2 and 2 would cancel out right there, and I would just be left with pi over 3 from the beginning. I don't care whether you simplify at the end or simplify at the beginning, but it's nice to notice those opportunities to simplify at the beginning because you're saving yourself effort. Next one, 5 pi over 6 over 2. You may notice that the 2 and the 6 could be reduced if they were in the correct position. The problem is they're not. The 2 would have to be reduced with the 5 pi, not with the 6. The 2 is the numerator of the denominator, so it's really 2 over 1. 2 does not simplify with the 5 pi, so that is not an opportunity available to us. But what we can do is just move the 6 downstairs to make it a 12 on the bottom, and we have 5 pi over 12. And finally, 2 pi over 2/3. This time I'm going to notice, keep in mind that 2 pi is over 1. That 2 pi is the numerator of the numerator, and this 2 is the numerator of the denominator. So if I wanted to, I could just cancel those 2's right now. If I didn't want to cancel those 2's right now, I could move the 3 upstairs, and then I could cancel those 2's at this point. It doesn't matter when you cancel those 2's, but don't make the mistake of multiplying it all the way through before you cancel those 2's. So final answer would just be 3 pi. So that's it for part 3. Go ahead and complete the practice assignment next, and then move on to the video for part 4.